Okay, so I want to do, wait a second, I want to do that one. No, I want to do that one. So we talked about what the three things that the primates have in common, and then we ended up here. Did we finish this slide or just start it?
No, we almost finished it. We got halfway
Okay,
there.
we got down to here? Okay, so we talked about how, primates in general are quadrupedal. You're an exception to this. That means they use 4 legs to move around. One exception to this other than you are brachiators who swing from their arms in the trees. And you'll see brachiation in action when we go to the Gibbons Center. The gibbons are the fastest brachiators. They fly through the trees at the fastest speed of anything that doesn't actually fly. And some of the larger apes do brachiation too, but they do it much more slowly. Like orangutans will use that as a method of movement, but they don't swing really quickly like the gibbons do. The gibbons are smaller and faster, basically. So you find brachiation among the apes. All apes, and this is actually true of humans too, and we're closely related to these groups, obviously, have modifications, adaptations to the shoulder joint, which permits this kind of movement, actually, that monkeys don't have. So one of the main differences between monkeys and apes is the fact that apes don't have tails and monkeys do. Sometimes you can't see the monkey's tail because it's kind of hidden in their fur, but it's there, whereas apes don't have a tail. They have an internal tailbone like humans do. Another difference, and there are some others as well between monkeys and apes, but another difference has to do with the structure of the shoulder, which is modified in apes for this kind of movement. It's modified in you too, but other changes that have happened to the human lineage mean that for the most part, as an adult, you don't move through brachiation. But when you're lighter and smaller, you actually do this like on the playground with the monkey bars, right? You can still do it. It's just a bit challenging, and you'll probably dislocate your shoulder or something, but give it a try. Prehensile tails, which are technically, for the purpose of the assignment, mean that your tail can support your full body weight, but it really also gets often used to mean grasping tails, but really a truly prehensile tail can hold up the body weight of the creature that has it. And you find that among some platyrrhines. You have semi-prehensile primates like capuchin monkeys that can use their tail to grasp and balance themselves and kind of hold themselves up to some extent, but they can't really, as adults, hold up their full weight, so they tend to use a hand as well. They're still useful in terms of finding food, but they're not truly prehensile capuchins. Oops. Let's see here. Pull this one out. Not that one. This one. Marmoset? Yeah. Yo, marmoset. Primates in general have certain characteristics. They have erect posture in the upper body, meaning that when you're sitting, the upper part of your body points up, like yours is right now. You're doing this now. That's erect posture in your upper body. We have hands and feet that can grasp. Humans, in spite of bipedalism, generally retain some grasping ability with their feet. My brother was particularly good at this when we were kids. He could pick up things with his feet. But other creatures that aren't bipedal like we are tend to have better grasping ability with their feet. Chimpanzees, for example, and other apes that hang by their hands in the trees can generally do pretty much anything with their feet, and they have opposable toes as well as an opposable thumb on their hands, so they can hold food quite easily with their feet. We don't do this so well. It's kind of one of the costs of walking on 2 feet. Your toes aren't so useful anymore, and your big toe is now in line with your other toes as opposed to, it's not opposable like it is among, like this is a good example of an opposable toe. Right, this is a gorilla's foot. The features of the hands and feet across the primate order include 5 digits. There are a few creatures who have reduced numbers of digits. They've lost a digit or they've got a stub, but 5 is the norm. Opposable thumbs are the norm too, although anthropoids have more dexterous fingers, better grasping ability than prosimians, and some prosimians don't have truly opposable thumbs. You have the most dexterous hands of any species, basically. And the chimps do pretty well. They're not as good as people, but they're probably next in line. A partially opposable great toe is the norm, though again, there's a lot of things you find commonly in the primate order, but then there'll be some exceptions, like humans are an exception to a few characteristics, and this is one. We all have tactile pads and sensory nerve fibers at the end of our digits, so the tips of your fingers are extremely sensitive, and that's no doubt due to the important role your fingers play in finding food, and the fingers have played this role throughout evolutionary history. They're also good for grooming, but it seems to be mainly related to finding food. I learned this the hard way when I was living on the reservation doing my field work, and I had a coal stove, and I accidentally one night tried to close the door of my coal stove, which was burning hot, with my bare hand, and I burned the skin off of my fingertips. Like my hand stuck to the door. I had to pull it off, and my fingertips were gone, which was really kind of cool. It was like I watched my fingerprints grow back, right? Because they were totally gone. I was like, oh, wow, that's neat. And it hurt so bad. I couldn't believe it. It was the most painful thing I've ever felt. I had to sleep at night with my hand in a bucket of ice water. And I was afraid I was going to pee. Because, there's that whole thing about how, like, when your drunk friend passes out, if you put their hand in warm water, they'll, like, pee themselves. But it doesn't work if it's cold water, so I was okay. I learned that through a scientific experiment, not of my own devising. Let's talk a little bit about types of locomotion. There are different ways primates move. Generally speaking, primates have a large variety of ways to move. As a group, they are generalized in their adaptation for locomotion. A number of species will move in different ways. And when I ask about locomotion on your primate assignment, I'm asking about the primary way they move, right? So the primary form of locomotion for human beings is bipedalism. However, when you're a baby, you're a quadruped, right? So and you theoretically can move other ways if you need to. If you need to crawl through a tunnel or something, you can do that. If you need to swing on the monkey bars, you can do it. You're capable of doing those things as the need arises. It's just your normal means of locomotion is on 2 feet, right? Now, if you think about in our world today, you don't face a lot of situations where you have to crawl around on the ground because we've constructed this whole world to accommodate the fact that this is how we prefer to move. But if you were living in the wild, in theory, it might be something necessary for you to actually move in some other way. And if you had to, you would, as any rock climber will tell you. So we're kind of generalized in our locomotion, but everybody's got a primary way they move. And a couple of different types of primary movements are quadrupedalism, which you find on the ground and in the trees, and it's a little bit different in each. It's also in the trees known as branch running and walking. That's another term for arboreal quadrupedalism. Brachiation is shown here. This is a time-lapse photograph of a gibbon swinging, and you'll see that in real life much quicker than that. And then vertical clinging and leaping is when an animal, and it's always a prosimian, starts vertically and then kicks off the tree and then spins around and then lands on another tree. This guy's about to land on another tree here. And that's a vertical clinger and leaper. I ask on your assignment whether or not your species is a vertical clinger and leaper. Remember that I'm asking if that's its primary type of locomotion. So if you have a marmoset or a tamarin, you will find online in the literature that marmosets and tamarins can move by vertical clinging and leaping, but it's not their primary way of moving. So don't mark yes unless it's primary, okay? It's most common among shiffox, tarsiers, and some of the lemurs. Terrestrial forms of primate locomotion are basically divided between quadrupedalism and bipedalism. There's a specialized form of quadrupedalism called knuckle walking, and that's where you use the knuckles of the front limbs as the point on which you rest and walk. Okay, that's a little bit different than the baboon. The baboon walks on the tips of its fingers. The gorilla or the chimp walk on the knuckles. Okay, but they're both forms of quadrupedalism because they're using all 4 of their limbs to move. Humans are special. Humans are special. And we'll talk about the evolution of bipedalism, which is a really interesting question. It's like, what does the fossil record tell us about bipedalism and how it came about? Are there advantages to it? Why would it have evolved? Weren't we just fine running around on 4 legs? Does it give us any possible advantages? Well, I can tell you that one advantage it doesn't give us is speed. You're actually faster on 4 legs. Not you personally, but species that are quadrupedal are faster than bipeds, right? So that's not it, but it does do some other things for you, and we'll talk a little bit about those. Now, when you look at the skeletons of various species, you can see adaptations for movement in the characteristics of the skeleton. Right? So remember in the film they made the point that the correlation between social group size and brain size among primates was such that if you showed a primate skull to a researcher, and they were talking about monkeys in particular, if you showed a monkey skull to a researcher, even if they don't know what species it is, they could figure out the size of its social group by the size of its brain relative to the body, or relative to the size of the skull, in fact. Well, basically, here is a comparison. You can do the same thing. When you start looking at skeletal anatomy, you can learn how to deduce things about the skeletons you're looking at. This is what forensic anthropology is. Forensic anthropology and forensic science are people who basically can look at a human skeleton and tell you information about the individual that skeleton belonged to when they were alive. Okay? So it's fairly easy when you look at a human skeleton to tell whether or not you're looking at a male or female. You can also figure out the age. You can make a pretty good guess as to what the ethnic background of the person is, although that's somewhat imprecise. You can also, as far as their species go, tell things like what type of movement it engages in. Okay? So, this makes it easier because it shows the skeleton actually in the process of movement. So here we have 2 quadrupeds. This is a terrestrial quadruped, which is a savanna baboon. This is a bearded Saki monkey from South America, which moves by branch running and walking. Now that's obviously shown to you, so it doesn't require any deduction. But if I were to disarticulate these bones, separate them all apart, and throw them on a table, right, and say to you, look at these bones and tell me the way this creature moves, right? They're just a pile on the table. You could look at the bones and figure out its movement. Now, you may have to reconstruct the whole creature, but if you think about it, like comparing these 2, right? These are both quadrupeds, but this one's on the ground and this one primarily. Baboons do go in trees to sleep, right? But primarily a terrestrial creature, and this is almost completely arboreal. And, even in terms of them both being quadrupeds, you can still see that they have skeletal differences between them that relate to the fact that this one is in the trees and this one is on the ground, right? So let's say I put a pile of bones of each of these creatures on 2 tables next to each other, and I said, figure out which one moves around in the trees, which one is arboreal. What bones would you look at to figure out whether or not it was arboreal based on comparing those 2 things? Okay, what do they tell you?
Well, the arboreal has a smaller ribcage.
Okay, do you think that has anything to do with it being arboreal per se, though? Or is it just that this species has a smaller ribcage?
Maybe the position of its legs makes it that its ribcage would be smaller.
Possibly, but I would say that as far as scientifically figuring out which one moves in the trees or not, I'm assuming you don't know anything else about arboreal creatures per se. Maybe if we look at all of them, they do have smaller rib cages. Why that would be isn't altogether clear. So even though this rib cage is smaller than this, I'm not sure that is like a smoking gun that tells you that this is an arboreal creature per se. What other features would you say?
The tail?
The tail might help. Why?
They need it longer so they can stabilize?
Yeah, they need longer and stronger tails for stability. Okay, so the tail would be a good one. And if you think about the fact that apes don't have tails, right? Is this a coincidence? I don't think so. There's very little that's coincidental in evolution. If you are moving by brachiation, a tail doesn't do you much good for balance, right? So if brachiation is the main way that apes in general move, that seems to be related to the fact that they don't have tails. Now, baboons still go up in the trees, so their tail perhaps serves some usage in terms of balance, but it's not as important. And you might even argue that if, given enough time of living on the ground, their tail might be continuously reduced as well. But certainly it's not as prominent as the Saki monkey. Love the tail answer, yeah.
Looks like the newer monkey can grasp better.
Yes, this is also terribly important. You might look at the digits, right, on the hands and feet. Because if the baboon is walking primarily on its toes, it doesn't really have to grasp around things like arboreal creatures often have very long fingers. Unless, right, if they have tiny little hands like a marmoset, their fingers aren't long enough to reach around the branches, so they have what? They have claws instead of nails, right? That's why you find claws instead of nails among marmosets and tamarins. Larger monkeys, though, like a Saki monkey, are going to reach around the branches and have longer fingers for doing that. Okay, that's great. There are other things too, and this would be harder to figure out if I gave you a pile of bones on a table, but arboreal creatures have more flexible spines, right, because they have to have that kind of flexibility. And you can't necessarily, you can see that, quote unquote, to some extent in this illustration, but the hip attachment, what do you think about that?
How the spinal column is more attached to the hip with the arboreal one. Let's say, for example, he uses his tail to like grasp branches and stuff. Like he'd be more in contact with his entire body, whereas the other one would probably not be as much as the other.
There's more flexibility here. I'm not sure saying that it's more attached is the right way to put it, but yeah, you're definitely onto something. What do you think?
It looks like the joints allows him to stay lower.
Yes, he's not as tall. He's not as tall up, which might be something that's useful when you're a terrestrial quadruped because you got to see what's coming at you. So baboons will stand up and look around. And in fact, one of the hypotheses about the evolution of bipedalism in humans relates to the fact that by being up like this, you can do certain things that you can't do when you're on all fours, right? Notice, for example, when the vervet monkeys were stealing the alcoholic drinks, they would grab it with their hands and then walk like this, right? And then they would sort of look almost human-like. Well, nobody's hypothesizing that stealing alcoholic drinks at a Caribbean resort was the reason why humans became bipedal, but perhaps carrying things in general was more important, right? So, yeah, those are all great answers. One other thing I should point out to you that has to do with your assignment as well, that I haven't explained, although some of you have no doubt looked it up and found out the answer, is this question of the intermembral index. Has anyone looked it up? It tells you what it is in the book, and the data for the intermembral index is actually commonly found in the row book when you get your row book entries for your species. But basically, it's a measurement of the limbs, of limb bones. And I don't do skeletal anatomy in this class. Sometimes if you take physical anthropology, they make you memorize all the bones in the body. I don't do this, whatever. You can look it up on the internet if you want. But basically, an intermembral index is essentially, if you want to think of it like this, the length of the arms, that's an R, arms, divided by the length of the legs times 100. So that means if you have legs and arms that are exactly the same length, what is your intermembral index? 100, right? If your intermembral index is below 100, what does it mean? Your shorter arms than legs. Is your intermembral index less than 100 or more? It's less. It's actually in the low 80s, but it depends on a couple of things. What is your background? What population do you come from? Also, there's variation within populations on limb length, and also females tend to have longer legs than males. But generally speaking, humans are in the low 80s. Essentially, your arms are probably approximately 80% the length of your legs. Probably. That's the average. Vertical clingers and leapers have even lower intermembral indices than we do. Their legs are even longer proportionally to the length of their arms. They have little tiny arms like this, which is why if you ever see a shifaka on the ground, it has to walk like this, or actually kind of skips. It goes like this because it can't reach down with its arms because its arms are so short and its legs are so long, right? So you wouldn't call it a biped because its normal means of locomotion is actually vertical clinging and leaping. But when they're forced to the ground, which they often are because they've cut down half the forest, actually more like 90% of the forest in Madagascar, they sometimes have to run between little patches of trees, which is no good because it makes them vulnerable to their predators, right? But when they do that, then they have to do this little skip along little thing, which the one in this picture is doing this right here. It looks like a baseball player, doesn't it? It's also got a baby on its back. Yes, probably would have gotten more runs off the Giants than the Tigers did. Ooh, oh, that was low. That was low. Sorry, Tiger fan. What's that? Can I do this? Do you like it when I do this? Yes, that could be an extra credit assignment. You get to move like a primate all day long and see how your friends react. Yeah, really? Yeah, I know. There's still that mating with a chimp option. It's still open. Speaking of vertical clingers and leapers, here's one injury. Shows you the long back legs as well as the position they start in. They too tend to have very long digits for grasping around larger trunks of small saplings and other trees. This is the skeleton of a brachiator, which is on the other end. These are the two extremes skeletally. And the brachiators have intermembral indices that are as high as the highest intermembral index among primates is about 150, where the arms are 1.5 times as long as the legs. And that's why when you go to the Gibbon Center, if you see a gibbon on the ground, they walk on 2 legs too, because if they try to walk on all fours, their arms are so long they get in the way. So what they do is they lift their arms up like this and they run around like this, because otherwise their hands will drag on the ground because they're so long. Okay, that's locomotion. Let's talk about diet and dentition. Now, primates have generalized diets and generalized dentition. Although, again, like locomotion, there tends to be something that primates eat. The majority of their diet is made up of one thing. One thing primates do eat a lot of is fruit. All primates love the taste of fruit. We all have this sweet tooth that humans have, actually. You can get, much like the alcoholic vervet monkeys in St. Kitts, you can get practically any primate species hooked on sugar. Actually, it's not just people. So frugivores are creatures who eat a diet that is high in fruit. So diurnal arboreal frugivores account for about half of all primates. Now the problem with fruit is it's not really available all year long, even in the tropics. It's available more often than you would think, but in the tropics, because trees fruit at different times. But frugivores generally have to eat something else. Nobody lives on an all-fruit diet, basically. There's no total frugivore, but it does make up the majority of food for a lot of primates. Generally speaking, we are omnivorous. You know that's true of people because you probably heard it. Omnivorous is sort of a word for meaning you eat a variety of things. Basically, it's this idea of a generalized feeding adaptation. In other words, you are more like the cockroach than you are like the koala bear. Although you may live your life like a koala bear. I have a friend who eats the same thing every day. It usually goes months at a time, then finally will change things. Like I think he's kind of got issues. He doesn't like to leave the house either. He's like somebody who's, no, he's not a monkey, he's a person. Friend, yes. I'm very close to the animals. I talk to the animals. I'm like Dr. Dolittle. So, yeah, he's sweet. I don't mean to criticize him, but he does this thing where he'll go to like the same restaurant and get takeout every day for lunch for weeks on end. It's really interesting. He's just like somebody who's really into habit. But he's still ultimately an omnivore. Now, our omnivory is shown in our generalized dentition, meaning that we have a variety of tooth types that do a variety of things. So most primates eat a combination of fruits, leaves, and insects. So do you. Now, in a lot of cultures in the world, eating insects is actually fairly normal, and they make sense nutritionally because they're high in protein. In our society, we have sort of a revulsion about eating insects. Has anyone eaten insects? Crickets? How about you? What have you eaten? Grasshoppers. Good for you. Grasshoppers very nutritious. They have more protein per pound than cows, than beef. They're also cheap and easy to grow. We have a world population problem with famine and hunger all over the world. We should all be eating grasshoppers, but people don't want to eat them. Yeah, I give extra credit to my cultural anthropology class to eat bugs on the first day. Bugs? Did I tell you the story? Oh, yeah, the first I bring in bugs and offer the students extra credit to eat them. Right, so one year I made the mistake of bringing in crickets, and that was a problem because they kind of jumped all over the room. And then we had to hunt them. It was really fun. But once a couple times I brought in those giant mealworms that people feed to like lizards and stuff. They're about this long, and they have kind of a crunchy exoskeleton. And I said, it was a class like this at a 1,000-point scale, and I said, I'll give you 5 points to eat a worm on the first day. And the first thing a girl raises her hand, she says, "Can I eat 10 worms for 50?" Right? It's always about negotiation. You guys are so funny. I said, "No way. I don't have enough worms. Next thing I'll have you eat the whole bowl, and what are the other students going to do?" She said, "I don't care." I didn't, and then I had to start setting up, fear factor anthropology. Then I had to start setting up, which I did this before that damn, I should have thought of that show, right? Then I had to do rules. Everyone wanted to use ketchup or drink a bunch of water or swallow it whole or like pepper or cook it or whatever. And I was like, no, you have to eat it raw and you have to chew it up. Okay? So needless to say, for 5 points, right, which is 1/2 of 1% on a 1,000-point scale, right, I ran out of worms. Everybody wanted to eat them. So they just lined up for them. It was crazy. And it was awesome. I know, yeah. The next year I was going to slaughter a goat in class. But and then I was down to the last girl, and she was obviously someone who had like a fear of insects, which a lot of people do, right? It's actually a common phobia. I'm really into bugs. I've always been into bugs. When I got my PhD in my anthropology, my mom was like, I'm really surprised because you always love bugs more than people. I thought you'd become an entomologist. And I was just like, bugs can't talk. So I was this poor woman. I put up pictures of bugs all the time on my Facebook, and I have friends who write back and say, would you please stop that? It's grossing me out or freaking me out. Right? So this girl in my class is like the last person, and she hadn't gone yet, and she really wanted the points. And so everybody was standing around still and in a circle. And she reached into the bowl and pulled out the bug, and it was like writhing in her fingers, right? And she's like looking at it, and she's totally freaked out. And everyone in the class starts chanting, "Eat it, eat it, eat it, eat it." And so she starts bringing the bug or the worm closer to her mouth like this, and she's like, and then she started shaking, and she was totally freaked out. And then she grabbed her hand with her other hand and started forcing her hand to her mouth. And she got it to like right here, and everyone was chanting, and she just freaked out and burst into tears, right? And this is one of the reasons why I stopped doing this. It was so traumatic, right? And I'm a sympathetic crier. Like if somebody cries, I just start crying too. I'm always like this. I watch a movie, someone cries, I'm like, oh my God, no, please stop crying. Or students come to my office and they're like, can you please change my grade? No. And then we just sit there. Then I cry too. And like, you can come to my office and cry. We'll hold each other. I'll cry too, right? So she's like crying. I'm like, oh my God, don't cry. And I'm like holding her, and she's like sobbing. And I said, oh, don't, it's okay. I'll give you the 5 points anyway. Don't worry. And then everybody else in the class was really pissed because they were like, wait, I ate the bug, and she gets the 5 points for nothing, right? It was a total lesson in social intelligence. The rest of the group was like ready to kill her, right? They're just like, I was like, okay, fine, I'll give all of you guys 10 points if you just leave her alone. And then she wanted to eat the bug again, right? So I gave everybody else 10 points because they had eaten the bug. I gave her 5, even though she didn't eat it because she was crying. And then she's like, well, can I still eat the bug for 5 more points? And I was just like, no, I can't go through this drama anymore. This is over, right? And that was the last time I ever fed bugs to my class. So anyway, you eat bugs too, you just don't know it, right? If you look on, those jars of fruit juice that you buy, the last ingredient and the little label on the back will say something like, and other natural flavors, right? And what that's referring to are all the bugs that get ground up with the fruit as part of the manufacturing process that are all in there. They're just like blended in with the fruit juice, and then you drink them. So you consume bugs too, even though you don't think you are. Okay, it's really important that you know that. I just want to make sure that every fruit juice, you've probably eaten so many bugs, you have no idea how many bugs you've eaten. Really? You should call the FDA. It's actually listed in the ingredients?
The label on the back, I don't even know if it had the ingredients. It was in the corner bakery. It said it has rainbows and happiness and all.
Those are probably common names of insects. Oh, that's so ridiculous. God. And yet you put it in your body anyway. Rainbows and happiness. That's great. Okay, so onward and upward. There are 4 types of teeth, illustrated here by this male drill. Not a mandrill, but a drill, smaller version, less colorful. Those 4 types of teeth are incisors. These go from the front to the back. Incisors, canines, premolars, and molars. Now, if you go to the dentist, they will talk about all of these types of teeth, but one of them they call something different. Do you know which one they don't use the term I've put up there for? No, canines are, your dentist will call them canines too. Premolars, they call something else. What is it? There's another word your dentist uses for premolars. Bicuspids. And the reason why they call them bicuspids is because your premolars have 2 cusps. So for humans, they're bicuspids. But for other primates, they don't have 2 cusps, so we don't use that word in primatology, right? But it's the same tooth. These are canines, incidentally, which are used as weapons for males. They're used for weapons for females too, but obviously fighting and competition for mates is more important for males, and they're one of those dimorphic traits that primates have that we've talked about. In addition to body size, sometimes males are bigger. The other thing that they have among primates is long teeth. Occasionally there's color differences, like the mandrill and the drill have colorful faces, the males do. But usually it's teeth and size. So the 4 types of teeth all do different things. And if we had more time, I could do it anyway. What time? I don't know. If we had more time, I'd do something which I do with my classes sometimes, and that's I give you food too after the bug talk. But your food is a sunflower seed. And I give you a sunflower seed in the shell, and I have you stick it in your mouth and eat it and spit the shell out. And most people will do this one of 2 ways. When you stick the shell in your mouth and you want to get the seed out of the shell, what do you do? With your front teeth?
Yes.
Yeah, a lot of people do that. Other people will move it over the side and bust it, then move it back and then break it open and use their tongue. But basically, by the time you swallow it, you probably will have used 3 of your teeth. You'll probably have used 3 of your tooth types. You'll use your front teeth to help crack it open. You'll use your tongue and your premolars, possibly your canines, that's the least common one, to open up the seed, and then you'll chew it up with the molars, which is what molars are for. Then you'll swallow it and spit out the seed. So it kind of illustrates the different functions of the teeth, but you'll have to pretend that we actually did it because we didn't actually do it. Okay? Let's stop here. We will pick up next time, you guys, at this point. Have a good day. Happy Halloween, Marmoset.